Good morning, everyone. This is Ben Weinstein, here to talk about the new version of MotionMeerkat 1.5. Since version 1.1, we've had a lot of interesting developments as I've gotten feedback from user community about how to further push automated monitoring for biodiversity forward. And I wanted to share some of the new tools I have, but overall the version 1.5 is faster, the code is much more elegant, and hopefully the user interface is a bit clearer. So I'm assuming that you've watched the first video, and here you've already installed MotionMeerkat. I have a desktop icon, but you could also access it through Program Files. Program Files, MotionMeerkat. And the interface looks the same so far. Again, remember that the wiki is right here for all of your help needs. All the arguments are there, as well as a command line version, which helps explain how to use MotionMeerkat and really fully utilize all the different tools. So here are the arguments, and in parentheses are the defaults and a brief explanation for each argument. As well as here are the command line arguments if you'd like to run MotionMeerkat in the command line. So for this video, I'm going to show a couple new options and explain a couple new pieces of code. We're going to use the same test file that comes with every single MotionMeerkat installation. It is of a hummingbird feeding on a flower, which was the original design for this project. You go to C Program Files, MotionMeerkat, and you can see that there is a test video here. There's the bird feeding very quickly. Again, one more time, bird feeding very quickly on a flower. And the rest of it is just background noise. So we can copy and paste this path. And as I said, the name of the file is plotwatchertest.tlv. I'm going to stick to the default destination, which is C MotionMeerkat. This is the area where the frames will be reprinted as well as any reporting. The first option is the accumulated averaging. This is the sensitivity to motion. Lower values are more sensitive, higher values less sensitive. Same thing for thresholding, lower values more sensitive, higher values less sensitive. And this is a very important parameter. For terrestrial organisms such as birds, I usually increase this value to about 90. For marine organisms such as sharks that move very silkily, I usually keep a very low value. This is the minimum motion contour size. Objects smaller than that percentage of the frame will be ignored, so 0.1% of the frame. I'm going to hit the default. And now we can run by just hitting enter, or we can say hitting advanced options, which is what I want to show today. So yes, I do want to say some advanced options. The first one is the adapt to motion sensitivity. This is you can provide an expected hit rate, and the algorithm will attenuate the sensitivity of motion until it hits the desired hit rate and returns that percentage of frames. We're not going to do that right now. That is most helpful for very long videos, hours of videos, where wind or other situations might change within the video and the original settings don't apply. Burn in is if you want to skip some initial minutes of the frame. Don't want to do that. So this is one of the new options that I'm really excited about. It's called scanning. And so if you had HD video or any other high quality video, those file types are encoded at 60 frames per second or 30 frames per second, which is just a tremendous number of frames. And what you're telling the computer there is that you care about motion at 1/60th or 1/30th of a second because every frame is reviewed. But animal movement at a 30th of a second is really fast, and you're not going to be able to identify anything at just a 30th of a second, nor are you going to care about 1/30th of a second to the next 30th of a second. So normally what I do for very high intensity videos that have high resolution is I scan. So I say, okay, only review 1 out of every 5 frames. And if that frame has motion, review the next frame. But I'm going to jump along the video until I find some motion. So if I do 1 out of every 10 frames and there's 30 frames per second, I'm still capturing motion at a third of a second. So it's still quite fast. And this greatly, greatly reduces the amount of review time and increases the speed of the program. In this video, because it's short, I'm not going to do that. I am going to set the frame rate because this is a time-lapse video and there was 1 frame per second. For normal cameras that have the metadata stored, if you're taking it directly off the camera, you do not need to set that option. This does come with Plot Watcher camera. Again, that's specific to my own needs. So here's another one of the new options. This is subsect an image by selecting a region of interest. This is if you want to crop or otherwise focus the algorithm on a portion of the frame. So you have two options here. I'm going to say yes. One is include, which means I'm going to draw a rectangle around a certain portion of the frame, and the algorithm's only going to look inside that frame. Or exclude, that is, I'm going to draw a rectangle around a portion of the frame, and the algorithm is going to ignore everything within that frame, which is what I'm going to do here. Often there is a timestamp on video files, and if you don't exclude that portion, the time clicking away will be registered as movement, and you will return all of the frames. Here's another new option as suggested by a MotionMeerkat user to highlight a region of the frame for an area count. This researcher wanted to count the number of times their animal moved into a feeding tray, but still have motion sensitivity on the entire frame. And so this allowed a separate file to be created that counts the number of times the object of interest is inside a certain area. And I'll show that as well. Frames output, you can either output the file as frames or video, which is a concatenation of all the frames together. We're going to stick with frames right now. So here it pops up a region of interest. So this is the area I wanted to exclude. So let's say that I knew that these leaves were moving a lot, but I didn't want to measure any movement inside that area because the hummingbird's going to come to this flower over here. So I'm going to right click and hold and drag a rectangle. It's very important that you go from the top left corner to the bottom right corner. That's the only way it'll work. So clicking top left corner and dragging with my right click, and then releasing and hitting escape, and a new image will pop up with that area excluded. Now I have to set the area counter, and so this is the area that I want to count. So I just want to count when hummingbirds come into this area here, and again pressing escape, and that pops up another frame showing me the area counter. And now it's running. Oh, I set the hit rate pretty high. So excuse me, it only returned one cat motion frame, but that's all right. You can see that it prints out the total runtime, the number of frames averaged per second, and the different reasons frames were rejected, as well as the overall hit rate. You can hit R to reboot, or any other key to exit. So I'm just going to hit enter, and I'm going to exit. So let's look at the output. So I told MotionMeerkat to save everything under folder C, MotionMeerkat, and it automatically created a name folder for every video. So Plot Watcher Test was the name of the video, and it created a folder. Oh, excuse me, this is from previous runs. There's other ones. Normally it would only return one frame because that's what it told you to do. But just because I had run it twice here. But we can still see what the frames output looks like, which is what I wanted to show. So only frame number 4 was returned. So excuse me, it would have been just this, frame number 4. And you can see it correctly captures the bird. And there's 2 small boxes here. And that corresponds to the 2 entries here in the Excel table. Frame 4 was in the 4th second, because there's 1 frame per second. And this was the X and Y location of those boxes. So you can create a track of your movement if you're confident that there are no false positives. So in highly controlled situations where you know that there's no wind or water movement, and you can trace the animals moving around the screen, you can use this table as an XY location of your organism. That's most appropriate in controlled situations, less so in outdoors where there will be some extraneous frames. Also, there's the area counter, which in this case is empty because no times was that bird captured within that circle or rectangle that I drew. But if it had, there would have been a separate XY location counter for just that area. And so these are both really helpful tools in creating ways of managing your huge data streams. There's also a file called parameter results, and it tells you the input file choices, so you don't have to remember anymore what parameters you used, as well as it returns to you that little report so that you'll have that in the file. Again, this would have only returned 1 frame. I had run this previously on a different setting, which is why it returned more frames. This would have been the only frame that would have returned if you had a brand new folder. Excuse me for that. So those are the new features in MotionMeerkat. I also want to make a plea for everyone to keep emailing me and keep using the GitHub issues page to help me move forward. I'm interested in every idea that people have and how I can make this better and how the community can be really motivated to start automating biodiversity monitoring. So don't hesitate to email me. You can find my email on my website, as well as potential ideas. No matter how far-fetched, I'm wanting to hear from you. So I hope everyone had a good day, and I will talk to you soon. Goodbye.